Mumbai's rain is legendary, and sometimes notorious. Remember July 26, 2005? 944 millimeters of rain in just one day. Streets turned into rivers. Trains stalled, the entire city ground to a halt. But can we actually predict events like this? That's where math and statistics come in. Let's start with IDF curves. Intensity, duration, frequency. Picture a graph. One axis is how hard it rains, the other is how long it lasts. These curves help engineers figure out how likely is it that this much rain will fall in, say, an hour or 10 hours. It's not just guesswork. Based on decades of actual rainfall data, weather stations rain gauges all over Mumbai. Then there's the return period. You'll hear things like a 100-year storm. That doesn't mean it happens every 100 years, but that, on average, there's a 1% chance of it happening in any given year. These numbers help city planners design drains, flood defenses that can actually handle the worst. But nature doesn't always play by the rules. That's why statisticians use things like the Gumbel generalized extreme value distributions to model the wildest, most extreme rainfall events, outliers that smash records and flood streets. It's called extreme value theory, and it's how we try to get a grip on the rare but devastating downpours. Now, add climate change and urbanization to the mix. Climate change, urbanization. Tall buildings, concrete change how water flows, and global warming can supercharge storms. That's why scientists use climate models like GCMs, RCMs, to simulate possible futures for Mumbai's monsoon. Long story short, analyzing Mumbai's rainfall isn't just about looking at clouds and hoping for the best. Digging into the numbers, building models, constantly updating our predictions as the city and the climate changes. That's how we stay one step ahead of the next big flood.